All right, so equations with brackets. So we're learning to solve equations with brackets, and we're learning to solve problems that involve equations, okay? Some with brackets as well. So we're going to start off just how to solve equation with brackets. The first step is to expand the brackets. So that distributive property that we learned, and we just kind of did with that perimeter question, that would be your first step here. Okay, remember the 2 shakes hands with each term in the brackets. So 2 times x would be 2x plus 2 times 3 is 6. Okay, so that's your first step. Now it turns into last Friday's question, a full week ago though, we have to remember that. So our x's are on both sides of the equal sign. So we either have to add or subtract to get them together. Okay, same thing on both sides. So I'm going to choose to create my 0 pair with this x and subtract x. And I know that in my heart that means I'm subtracting 1x. Okay? So x minus x is 0. 2x minus 1x is 1x. Is everybody good with that? 2x minus 1x. So, and I can just write x. I don't have to write 1x. The 1 is understood to be there. X and 1x are the same thing. I still have the plus 6. And on this side, I had a 0 pair, but I've got the negative 7. Don't forget the negative sign there. Now the side with x, it's only on one side now because that was my second step there. It tells me what to do next. So I want to undo this add 6 by subtracting 6. But whatever I do to one side of the equals, I have to do to the other side. So I'm going to end up with negative 7 subtract 6, which, careful with integers, negative 7 subtract 6, you're going further into the negatives, is negative 13. Or use your calculator and type negative 7 minus subtract 6. Okay? All right, so same idea with B. Your first step is going to be to distribute on both sides. So see if you can write out what the first line would be. Just see if you can remember the distributive property. Probably day 2 or 3 of last week. How do you expand those brackets? Nice. Awesome. So I see lots of 6a plus 12s for this side, which is awesome. And lots of 4a minus 12s on this side. Okay? Any questions how to get any of those terms? Everybody okay with that? That's the distributive property. Okay, so now I want to get my a's together. They're on different sides of the equal, so I have to add or subtract to get them together. Okay? So I'm going to take away 4a and make a 0 pair here, so the a's are gone from this side now. Does everyone see that? I made the 0 pair there, so there's no a's on this side anymore. On this side, I have to do exactly the same thing. So 4a. So 6a subtract 4a is 2a. I still have the plus 12. On this side, I have negative 12. So now here's my variable, a. It's only on one side, it's only in one spot. So I now use reverse BEDMAS. Okay? So on the side with the a, is there any adding or subtracting? Yes, there's an add 12, so I'm going to subtract 12. On both sides. Then I'm going to use my brain or my calculator. Negative 12 subtract 12. We're going more negative, so it's negative 24. And then I'm going to divide by 2. So So then either in my brain or my calculator, negative 24 divided by 2. Negative 12. Okay. All right, I'm gonna just give you time to try C on your own. Okay, Xavier, you have the first line. First one.
16
Yep.
into 6 and
Perfect. Okay, so I saw that pretty much universally, or not everybody had the first line right. Excellent. So now we have to notice that we've got n's on both sides. Okay? Notice how on this side I have a negative n. Does everyone see that? It's a negative n or a negative 1n. So when I see that I have a negative on one side and a positive on the other, I always want to make things positive. Okay, if I can. So I'm going to add n to both sides to get my n's together. Okay, and as I walked around, a lot of people chose that path as well. Some people did it, some people liked everything on this side, which is fine. So there's my zero pair. Negative 1n plus 1n is 0. So I'm left with 16. And then 6n plus 1n is 7n. You've got to look at that as a 1n, so 7n. So now the right side is the side with the n this time. Okay? So it's the side that's going to boss me around. I want to undo the add 2, so I'm going to subtract 2 on both sides. So I get 14 equals 7n. And end up getting n to be 2. And I saw lots of people get all the way down to n equals 2. Way to go for a Monday morning. Really good. Okay, I'm going to put a little star beside D because there's a little hazard. I want everybody to try the first line, and then I'll get somebody to tell me what their first line is. Everyone try it, because if you make the mistake, you won't make it again. Okay? So as I was walking around, I saw a lot of people started off writing out this side because it looked easier to them, which is a smart strategy. Okay, do what's familiar to you. What was bothering people about this side? Who thinks they know this side? Yep.
I don't know if it's right, but I wrote down 8x minus 16 equals 4x.
Okay, so I'm so glad you did that because you did the 5 plus 3, right? And that is why I put a star on this question. Because if you use BEDMAS, you have to multiply before you can add. Okay? So even though that 5 plus 3 looks so enticing, and you want to do it, you want to do 5 plus 3, this 3 beside a bracket means multiply. So when you're thinking BEDMAS, you have to multiply the 3 through before you add the 5. So what this side should look like is just keep the 5 there for now, and then distribute the 3. So plus 3x minus 6. Okay? So as I walked around, I saw probably about 6 of you do the 5 plus 3. Okay, that was in your head, and that's why I put a star there. Common common thing to think. It's very enticing. It looks like I want to just add those. I know the answer. But you gotta remember, you gotta distribute first, you gotta multiply before you add. So now you could collect the 5 and the -6 on this side, because they're both on the same side of the equal sign. And you could rewrite this side as -1 plus 3x. This 5 and -6 is -1. And now you've made it into one of those equations where you've got the variable on both sides. Okay? So you want to decide how to get the x from being on both sides to just in one side, just in one spot. So I'm going to choose to subtract 3x. Okay. 4x minus 3x is 1x, or I can just write that as x. And then I want to get x by itself. So I want to undo the add 10 by subtracting 10. And I'll end up getting x equal to -1 minus 10, -11. Yeah. Yes. All right. Try E on your own. Okay, so to avoid double signs, -4 times x is -4x, and we want to write plus there, but refrain from doing that. -4 times +6 is -24, which everybody got, but instead of having plus -24, just have -24. Okay? So don't put the sign here down until you know whether it's going to be positive or negative. And then you'll avoid double signs. Similarly here, 6x, don't write a sign down. 2 times -4 is -8, so -8. So that should be your first line. Okay? What was your next thing that you did? Somebody that's finished 3D. Blaine.
I added 4.
Awesome.
On both sides.
Perfect. So you would get -24 equals 10x minus 8. That's all you got. What was your next step?
I added 8 to the side.
Perfect. So then you would get -16 equals 10x.
And then I divided step by step.
Good. Which gave you?
I did it wrong, so I didn't get the answer. Because I got that the 4 for the 24, so I just put the -2.
Okay. Did everybody get to this step that's got there? Okay, so I have two choices now. I can just divide and get -1.6, which is fine, okay? Or I can say my answer is a fraction, and then just reduce that fraction to lowest terms, okay? So I can see both numbers are even, so I know at least 2 goes into both of them. So if you divide top and bottom by 2, you can write it as -8/5. Then you can check and see, does that reduce anymore? No. So either one of these answers is correct. Okay. All right. For F, I want you to try the first line. Okay, see if you can get the first line. There's a little, you better put a little star there. That negative sign in the middle may be an issue. See if you can expand out what your first line would be. Remember, don't put a sign down until you know what it is. Yeah. No, that's on a different side, so that's really -1. And then you just use it. Remember, don't write the sign until you know whether it's positive or negative, so you don't end up with double signs.
Did you rearrange the one?
Huh?
Did you change the thing?
Yes, I do that every week.
Okay.
So that I don't have some people sitting in the
Fair enough.
front all the time with backhoes and.
Just confusing.
Sorry.
I'm getting confused.
So the big important thing for this one is that you put a 1 here, and then you distribute the 1. Okay, so you've got the 5 multiplying this bracket, and then the -1 is multiplying this bracket. Okay, and then you have your equal sign to 19. So your first line, anyone brave enough to say what their first line is? Amelia.
5m minus 15
Yep,
minus m
yep.
plus 2 equals 9.
Perfect. Okay, that +2. -1 times -2 is +2. Okay, don't write the sign down until you know what it is. Perfect. So now we have one of these equations where we only have one thing on the right side and a whole bunch of things on the other side. So what are we going to check for? Like terms. Okay? So I've got a 5m and a -1m. Both on the same side of the equal sign. So really on this side of the equal sign, I've got 4m. Does that make sense to everyone? 5m take away 1m is 4m on this side. Okay? And on this side of the equals, I've got -15 and +2. So I really have -13 on the left side of the equals. And then I've got my equal sign, and then I've got my 19. Okay? So when you have things that are on the same side of the equal sign, you collect the like terms. You don't have to add or subtract to make 0 pairs. You just collect them and simplify that side. Okay? And then once you've done those steps, you've turned it into a fairly simple 2-step equation from our first week on solving equations. We've only got our variable m in one spot, and we want to use reverse diagonals to get it by itself. So on this side, we're looking to see if there's any adding or subtracting to undo. Add 13. $19 and 13 is 32. And then I want to undo multiply by 4, so divide by 4. And we'll get m equal to 8. So that one actually is worth a start there. Okay, there was a couple things. First there was the -1, and then we had the like terms on the same side. And it's been a week, so we're going to be a little bit rusty on these. Okay, so this one is similar to this one, where you really want to do the 5 plus 3, but you can't. You can't do that 7 minus 3 because you have to multiply through there. And you're not just multiplying a 3, you're multiplying a -3. So see if you can come up with what your first line would look like for this one. If you have stated that, what do you think your first line would look like for that one? Remember, don't write a sign down until you know what it is. Okay, who wants to tell me their first line? Yep,
7 minus 6x plus 15 equals -3.
awesome. Okay, so as I walked around, everybody had the 7 minus 6x. A couple people had minus 15 here. Okay, so just remember, you were doing -3 times -5 is positive 15. Okay, and everybody had the 7 minus 6x. A lot of people had plus 15, which was great. Next equals -3x. Minus x. Okay, and then I saw people adding 6x to both sides, which made my heart happy. Because that's going to leave me with a positive number of x's on this side. And then I could also, on this step, if I want to, add the 7 and the 15 together. So I got rid of, or I added, created a zero pair to put the get the x's together. And then I saw, well, on this side I'm left with 7 and positive 15 to add together to give me 22. Okay? So now my x is on one spot, in one spot. To undo the subtract 3 here, I'm going to add 3 to both sides. Zero pair. Then I want to undo multiply by 5, so I'm going to divide by 5 and end up getting x equal to 5. Okay, so again, this one should be starred. That's like a hard one too for brackets. Make sure everyone's got that. Now I've got a few problems to work on, and then I'll have some practice for you to do. So I'm going to just give you time for this problem because you guys are pretty good with this type, which is really great. So everyone's realizing this side's 2x plus 7 and this side's x plus 3. I have a few counter-rounders that went straight to the answer. Most people, they labeled it rectangle, which made me really happy. And then they added up the 4 sides to get perimeter. 6x plus 20. How many people got 6x plus 20 for the rectangle? Okay, awesome. No matter which way you did it. So then I saw some cool things for the octagon. I saw some people doing adding up x minus 4 8 times, which is perfectly fine. They were checking to make sure they had 8 as I was walking around. And then we got 8x minus 32. Yep, okay. And then I had other people that said the perimeter of this was 8 times, in a bracket, x minus 4. Okay? 3 people did that. Is it going to give me the same? It should, right? Does that make sense? One side's x minus 4 is an octagon, so they're all the same. There should be 8 of them. And if you distribute, you do get 8x minus 32. You see that? So you could have done it either way. All right, the main thing though is that they have the same perimeter, the same. So if I want to solve for x, this perimeter of my rectangle and the perimeter of my octagon are equal, they're the same. So this is the equation I can make. I can say that 6x plus 20 is the same as or is equal to, equals such an important symbol in math, 8x minus 32. So their perimeters are equal. The perimeter of the rectangle is equal to the perimeter of the, I'm not going to draw one, octagon. Those perimeters are equal. Okay? So once you know that, you've got an equation that you can solve to get x. So you want to get x by itself. Okay, they have the same perimeter, so the perimeters equal each other. We can set the perimeters equal to each other and solve for x. Nice. Okay, so I'm seeing lots of people subtracting 6x from both sides. 2x minus 32. Then adding 32 to both sides. Dividing both sides by 2. And getting x equal to 26. Okay? Good job. All right. Similar type of question, except for you're given the perimeter, so maybe it's a bit easier. So you're given the perimeter of this shape is 67 meters. And they want you to determine the length of each side, but in order to do that, you need to know what x is. Okay, so you need to find x first. And then the little trick here is that you have to distribute here and here before you do your tally. Okay, so that you're adding up the correct values. Sorry. Or if you're counting around, same thing, just get the right values there before you find your perimeter. Okay, so I see a lot of people with 2x minus 2 here, which made me happy. A lot of people would have put 2x minus 1 last week, so we're catching on to the distributive property. So once you've got all 4 sides, you want to add them together, either by a tally or counting around or side by side, like terms. Alright, so add them up here. Oops, 20. 12x plus 17. How many people got 12x plus 17? Did I miss something?
Yeah, I think it's 2x plus 10, not 2x.
You're right, thank you. Good. All right, so it's 12x plus 7, correct?
Yeah.
Okay, awesome. So we know the perimeter is 12x plus 7, but we also know the perimeter is 67 meters, so I can make that equation, and then I'll be able to know what x is, okay? And then once I know what x is, I can figure out what all 4 sides are, okay? If you're asking me. So here I got x equal to 5. Everybody good there? And it would be meters. All right, once I know x is 5 meters, how do I figure out how much a side worth? Anyone, how would I figure out one side? No, x is 5 meters. Any ideas? How would I figure out this side, for instance? 5x minus 1. Yep. 5 times 5. Good. So I'm replacing x with 5, substituting using brackets, minus 1 is 25 minus 1, which is 24 meters. Okay, so this side is 24 meters. Everybody good? 3x. I'm going to do 3 times 5, so this side is 15 meters. This side, I might as well use the 2x plus 10 since I've already done the work on it. So I'm going to replace x using brackets with a 5. 2 times 5 is 10, plus 10 is 20 meters. And then my fourth slide, 2x minus 2. 2 times 5 minus 2. 10 minus 2 is 8 meters. And if I add my 4 sides together, what should I end up getting? 67. So it doesn't look proportional, but let's see if we get 67. So 24 plus 15 plus 20 plus 8, 67. Okay? So you can check your answer. So this one was easier to find x, but then we had to use x to find the lengths of all 4 sides. Okay, so that took some time to do. So our last 2 questions would have been typical solving equations questions for me when I was in high school. We still do them, just not as many of them over and over again. So this is a typical solving equation word problem coming at you. Ken has 3 times as many video games as Jesse. Altogether, they have 68 video games. How many video games does each person have? Okay, it's a classic solving equations question. So the first step for me to make it easier is I like to write something out in words. Okay, so I know that Ken and Jesse in total altogether have 68 games. Everybody good with that? Makes sense? So I would write out Ken plus Jesse equals 68. Okay, I'd start off like that. So if I know the number that Ken has and I add it to the number that Jesse has, I know that the answer is 68. Does that make sense to everybody? Okay, then the next thing I do is I pick out who's going to be x, Ken or Jesse. Okay, so I want to read through the question. Ken has 3 times as many video games as Jesse. So who would it be easier for me to make x be? I think why do you think Jesse?
Because there's no number associated with Jesse's name.
Okay, that's a good way to go. Okay, so I'm not giving Jesse in terms of anybody else, but if I know how many Jesse has, all I have to do is multiply by 3, and then I know how many Ken has. So if Jesse has x, what's 3 times x? 3x. Nice. Okay. Now we have to be really formal about this, so we have to do a let statement. I don't know if you did these at grade 7 or 8, but here's what x is, and you can see. So let x be the number of games. I just use the hashtag symbol for number there. Number of games Jesse has. So you have to say what x means, in other words. Okay? So whoever you let be x, you always have to say let x be the number of whatever that person has. Okay? So I always make my word equation with the people's names. Then I figure out who x should be. Then I figure out how to write the people's names in terms of x. Then I do my let statement. and then I'm going to solve Rex to answer the question. So if you look at this equation, I've got like terms, 3x plus another 1x on the same side of the equals. So really on this same side, on the left side of the equals, I have 4 x's. Does that make sense to everybody? So I would divide by 4, and that's going to give me 17. Everybody good? What was x again? X was the number Jesse has, so therefore Jesse has 17 games. And all we have to do is multiply 17 by 3 to get 10, right? And Ken has 17 times 3, which is 51. Yes, 51. 51 games. So Jesse has 17, Ken has 51. Check and see if 51 and 17 adds up to 68. It does. You're done. Okay, and our last problem is another one like this. So Claire has twice as many jelly beans as Mark. Mark has 3 less than 5 times as many jelly beans as Helen. Altogether, they have 391 jelly beans. How many jelly beans does each person have? So that word all together means if you add up all their jelly beans, it equals 391. So we know we've got equals 391. And we know we're going to add up 3 people this time. Claire, Mark, and Helen. So your first line, I see people writing it down already. Claire plus Mark plus Helen equals 391. Claire plus Mark plus Helen equals 391. And when you're trying to figure out who's going to be X, ask yourself, if that person's X, can I figure out how much the other 2 have? Okay? Easily. As easy as possible. So for instance, how many Claire has is based on how many Mark has. Does everyone see that? So I'm not going to make Claire X. I might make Mark X, but I'm going to read on. Okay? Mark has 3 less than 5 times as many as Helen. So the number that Mark has is based on the number that Helen has. Do you see that? So I'm not going to make Mark X either, so that means Helen's going to be X. So let X be the number of JBs for jelly beans that Helen has. So once we've got Helen being X, then if we follow this sentence backwards, we should be able to figure out how many Mark has in terms of X. So work backwards there. Helen's X, we should be able to write how many Mark has now in terms of X. Because Mark is in terms of Helen. So Mark has 3 less than 5 times as many jelly beans. Who thinks they know how to write 3 less than 5 times as many? Yep. 5x minus 3, lovely. Good. okay? So 5 times as many means 5x, 3 less than that is subtract 3. So now I know Helen is x, and I know Mark is 5x minus 3. Now I want to know Claire. Well, Claire has twice as many as Mark. So if Mark has 5x minus 3, Claire has 2 times that. So I can put it in brackets with a 2 in front. And that's how many Claire has. Claire has twice as many. So 2 times as many as Mark. Mark has 5x minus 3. Claire has 2 times 5x minus 3. So now I've got my equation. And my first time through, I'm going to distribute those brackets. So I would get 10x minus 6 plus 5x minus 3 plus x equals 391. And this is one of those equations where I've got a whole bunch on one side and only one thing on the other. So I can check for like terms. And make this side much simpler. 10x plus 5 is 15 plus another one is 16x's minus 9 equals 391. X by itself, so I'm going to add 9 to both sides. 16x equals 400. And finally I get x is 25. And then you go back. Where did it start from? Who was X? Helen was X. So therefore, Helen has 25 jelly beans. Okay. Mark. How do I figure out how many Mark has? 5x minus 3, right? So 5 times 25, because x is 25, 5 times 25 minus 3 is 122 jelly beans. And Claire has twice as many as Mark, so I have to multiply the 122 by 2, 244 jelly beans. And then to check, you can add those 3 numbers up and make sure you get 391. And you do, check. Okay, so once you got that class done, you can go to break. I will save this for Reese. Oops.